This is lesson 9.5, combinations. Mr. Ruiz is making a salad for a party. He has tomatoes, green peppers, cucumbers, and radishes. He starts with lettuce and then decides to add 3 of the above ingredients to his salad. Use the first letter of each vegetable to list all the permutations of the ingredients added to the lettuce. How many are there? Well, here's my sample space right here. I have tomatoes, green peppers, cucumbers, tomatoes, green peppers, radishes, tomatoes, cucumbers, radishes, green peppers, tomatoes, cucumbers, and so on. This list, or this arrangement, is a list of what we call permutations, and those are arrangements in which order is important. In other words, tomatoes, green peppers, cucumbers would be different than cucumbers, tomatoes, green peppers. Cross out any arrangements that contain the same letters as another one in the list. How many are there? Well, let's see. If I go through my duplicates, this is a duplicate. This is a duplicate. And so are these 3. So I go from 9 permutations to 4. Explain the difference in the 2 lists. Well, again, the 9 permutations order didn't matter. In the 4 that are left over, order doesn't matter. Those are what we call combinations. An arrangement or listing of objects in which order is not important is called a combination. In the activity above, choosing cucumbers and radishes is the same as choosing radishes and cucumbers. Permutations and combinations are related. You can find the number of combinations of objects by dividing the number of permutations of the entire set by the number of ways the smaller set can be arranged. Terrence's Pizza Parlor is offering the special shown in the table. How many different 2-topping pizzas are possible? This is a combination problem because the order of the toppings on the pizza is not important. In other words, pepperoni sausage is the same as sausage pepperoni. So we make a list. We come up with all our combinations that start with pepperoni, then sausage, then green peppers, then onions, then mushrooms. Then we start to cross out the duplicates. Here, again, pepperoni sausage is the same as sausage pepperoni. And we cross those all out, and we go from 20 to 10. Find the number of permutations of the entire set. Well, we're picking 5 toppings, or 2 toppings from 5. So in step 1, we can pick 5 for our first topping, 4 for our second. That gives us 20. Find the number of permutations of the smaller set. That means 2 choices for the first, 1 choice for the second. We divide 20 by 2, we get 10. That's a way of calculating the number of combinations rather than making a table. How many different 3-topping pizzas are possible if Terrence adds ham and anchovies to the topping list? So that means instead of 5, he now has 7 choices. Instead of 2 toppings, he has 3. So you're going to do 7. You have 7 choices for the first, 6 for the second, 5 for the third. You have 3 ways to arrange the second, or the smaller set, times 2 times 1 gives us 210 over 6, which is 35. The answer is 35. A one-on-one basketball tournament has 6 players from the regional finals. Each player will play each opponent once. The 2 players with the best records will then play in the championship. How many one-on-one games will be played? Find the number of ways 2 players can be chosen from a group of 6. Well, 6 ways to pick the first person, 5 ways to pick the second person, 2 ways to arrange the first person, 1 way to arrange the second person, gives us 30 divided by 2, or 15. There are 15 games plus 1 final game to determine the overall winner. So there will be 16 games played. Make a diagram in which each person is represented by a point. Notice I have 6 points, hexagon. Draw a line segment between each pair of points to represent all the games. This produces 15 line segments, or 15 games. Then add the final game to make a total of 16. If the players in example 2 are selected at random, what is the probability that player 3 will play player 6 in the first game? Well, 15 possible outcomes, only one favorable outcome. The probability of 3 playing 6 in the first game is 1 in 15. What is the probability that player 3 will play against player 12 in the first game if 12 people play in the tournament? Well, instead of 6 players, we have 12. So we have 12 ways to pick the first person, 11 ways to pick the second person, 2 ways to arrange the first person of the smaller set, and 1 way to arrange the second person. So we get 132 divided by 2, which gives us 66 ways to arrange the people. 3 playing 12 would be one of those 66, so the probability of 3 playing 12 in the first game is 1 in 66. How many ways can you pick 2 stickers from a package of 7? For number 1, well, you have 7 choices for the first sticker, 6 choices for the second sticker. You have 2 ways to arrange the first one, only 1 way to arrange the second one. 42 over 2 gives me 21 possible ways to pick 2 stickers. Number 2, in how many ways can 3 out of 10 students be chosen to represent their projects or to present their projects at a science fair? Well, we have 10 ways to pick the first person, 9 ways to pick the second person, 8 ways to pick the third person. That's how many people we're picking. 3 ways to arrange the first person, 2 ways to arrange the second person, 1 way to arrange the third person. We get 720 over 6, which gives us 120 ways we can pick 3 people out of 10 to represent or to present their projects at the science fair. Number 3. Jade is going to paint a room 2 different colors from among white, gray, sage, or yellow. How many combinations of 2 paint colors are there? Well, she has 4 paints for the first choice, 3 for the second, 2 ways to pick the first one in the smaller set, 1 to pick the second one. We have 12 over 2, which is 6. Find the probability that 2 colors randomly will be white and sage. Because there's 6 possible outcomes, only 1 of which is favorable. The probability is 1 in 6. The only vocabulary in this lesson is combination, which is an arrangement or listing of objects in which order is not important. At this point, you should stop the video, go to NICU at www.nicu.net, log in, and take Lesson Quiz 9-5. Thanks.